So here today, I was able to sneak into Crystal Cove State Park. All the trails are closed. Everything's closed. And I think the reason I got in here because it's raining and nobody's around. Shh, don't tell anybody. So a couple of things I want to look at Crystal Cove while I'm here. Obviously this is a kiosk showing the map of where Crystal Cove is. So along the Pacific Coast Highway. And one of the interesting things that I wanted to look at that's here, that is probably the most northern extent of this formation. It's one that we saw when we went to Dana Point. And this is the San Onofre Breccia, the most northern extent of it. Everything else in this area is Monterey Formation. Unfortunately, we can't see a lot of the Monterey Formation because there's all of this stuff called biology that's covering up all the rocks. And by the way, this yellow pretty flower here, this is called mustard weed. It was introduced to California. It's not native. It's a fire hazard. It was brought here by the monks. They like mustard weed. I guess you can make mustard out of it. I really don't know. I'm not a biologist, so I don't claim to know. But it is not a natural native occurring species. It grows very well during rainfalls like this, and then soon as the temperature warms up, it dries, and then it becomes a fire hazard. So a lot of the chaparral, a lot of the fires that we're experiencing are the result of introduced vegetation, and mustard weed is one of the big culprits, especially along the coastal California. It loves coastal California. You don't find it so much inland as much. It loves the hills that face towards the ocean. It likes that little moist air that comes up in the morning, and that's how it survives until it gets too hot. So I'm at Crystal Cove. The next part is we're going to go down to the beach, so I'm kind of going to sneak around here a little bit. I feel like I'm a secret agent. Bond is the name. James Bond. So some of the rocks that make up the Monterey Formation are shells, there's conglomerates, even some breccias. But a lot of the shells here are enriched with a sedimentary form of quartz called chert. And chert generally suggests that the rocks were formed in a much deeper environment. So you have a lot of Monterey Formation that contains fossils, especially up north in the type locality in Monterey, California. Monterey Formation has huge pectin fossils in it. We see those occasionally down here, but what we're seeing in this particular area is more of a siliceous type of shell. A little bit of chert got in here. The black dark coloring is due to iron, although it did not oxidize because it's too deep of water to oxidize. And so deep water isn't going to be a good environment for fossils to occur. So that's why some parts of the Monterey Formation we don't find fossils, because the water was simply too deep, insufficient oxygen, no sunlight, and not a very good environment for organisms to live. Therefore, they never became fossilized. So I'm standing here on a bluff overlooking the Pacific Coast Highway coming down the hill here. You can't see below us. There's a set of houses out at the end of the cliffs right there. That's the beginning of Laguna Beach. I guess that big house out there on the end was built by one of the Irvine Corporation people, Joan Irvine. And this cliff bed out here is some members of the Monterey Formation. And we're going to go down and take a look at that, a little bit closer look, kind of sneak on down there. We're kind of doing this like undercover right now. And we'll kind of pan out, see the ocean. It's a gloomy day, raining. It looks like it might break up and clear up a little bit. Hopefully that will be the case. You can definitely see that the coastal setting here is one of a sea cliff, which is typical geological setting that dominates California. Unlike Bolsa Chica, our field trip where we went to last week, that area is basically controlled tectonically by the Newport-Inglewood Fault. The Newport-Inglewood Fault is in this area, but it's offshore quite a bit, and it runs offshore along the California coast, and it kind of re-emerges on land again down in San Diego County. So our next stop will be to take a look at the rocks overlooking that make up this nice little point here. Looks like the weather's beginning to clear a little bit here. There's a parking lot completely empty because Crystal Cove is closed. I will then travel down through the hills here and make my way down to this little tunnel, which will take us underneath the Pacific Coast Highway. And we'll take a look at the rocks on the other side. So we'll kind of zoom in over here next. So right now, I'm looking at a road cut along the Pacific Coast Highway here. And this is part of the Monterey Formation that's been cut into. So the largest portion of this formation here, this little road cut here, this Monterey, this is very fine-grained shells, kind of sandy shell to silty to clay, but embedded within are portions of harder rock, and this harder rock are actually what we refer to as chert nodules. So this is primarily made out of chert. So this shows that portions of this Monterey Formation occurred in pretty deep silicious waters. So that would have been water that would have been insufficient with respect to oxygen, which is why we don't find fossils in this part of the Monterey Formation at all. It was just too deep of an oceanic setting. And the chert nodules probably have been moved around a little bit, but they pretty much form in place. They form within the sediments, and they form because you got silica in a non-oxidizing environment formed, kind of congregates together. They form like little nodules of quartz, chert, and we call them chert nodules. And so this is a real indicator of the type of environment that this was a deeper water environment. So this is the tunnel that goes underneath the Pacific Coast Highway. This is the one I had planned to take. It's all blocked off, it's all closed because it's flooded. It's all the rain, and you can see that the sand kind of forms a little barrier here. Even the lifeguard vehicle decided to go around. Hey, if it was me, state vehicle, I would have gone through there, not my truck. So I'm now heading down along the beach and heading over towards these cliffs over here. And I'm going to take a look at this geology, and that'll pretty much wrap up our field trip today. It is getting a little bit clearer right now, so the storm system seems to be breaking up, which is good news. Okay, I'm approaching the cliffs here, and immediately you can see that this formation here is tilted. So it has an angle of inclination where these rocks, the layers, used to be horizontal, and they've been tilted almost 90 degrees. So realize that when these rocks were formed, they kind of were like this, and they went like this, boom, over tectonics. A lot of activity though. So these rocks are definitely tilted. And then there's a really cool house at the top of that cliff there. It's actually made out of rock. So whoever owns that house has some taste. Actually, the house is owned by Joan Irvine, who I heard passed away a couple years ago, part of the Irvine Corporation. So we're going to take a closer look at these rocks. So here I am right at the base of the cliffs here. And there's a lot of things going on here, geologically. You'll notice this kind of yellowish formation. This is oxidation that occurred after deposition of the rocks. As I pan down here, you're going to see that there's a lot of green within this rock. And when you see green, this is due to iron reduction. In other words, iron had formed in a reducing environment void of oxygen. So there's iron oxidation, which tends to turn rocks red or yellow. iron oxidation when you have oxygen. The more oxygen, the more red the rock becomes. Obviously, the amount of iron also has a large factor in the whole equation. But these rocks are certainly tilted. The geology here is really contorted. There's this area right here in between where you have some boulders, and these boulders kind of come down. And you can see up in the hill there's a lot of boulders up there that are incorporated. So this is what I would probably call a tectonic breccia. So there's obviously a fault, because we can see that the rocks over here definitely tilted, and then they lie against rocks that are not so tilted. You'll see some green inclusions in there. Those are the chert nodules. Moving over here, you see this rock suddenly becomes tilted, and then you get this kind of dark brown, and this is actually mafic. And the rocks that are forming in this are what makes up this pile of boulders here at the base. So these are basically erosional remnants. This is some type of an igneous intrusion, a sill or a dike. And the difference between sills and dike are primarily that sills run the same direction as the bedding plane and dikes cut across. And looking from the looks at this, it's hard to really determine if this is a sill or a dike, because God, the geology here is so contorted here, so twisted around due to tectonic activity, that it's really hard to determine. But it was definitely an igneous intrusion, a mafic igneous intrusion at that, because of the dark coloring. You can see that these rocks consist of things like gabbros. Mostly that's what this is. So this is very mafic. Some of the salts in here. Very mixed up rock formation here. And so the Monterey Formation, it's a very diverse formation. A lot of different geological settings in it. So we're going to conclude this field trip here. I'm going to go back to my editing room and edit everything and kind of give a little panoramic view here of the overall setting. Over there on the opposite side of the lifeguard tower over there, or the lifeguard station I should say, that was the road cut where I showed those chert nodules inclusions. We see that all along the Monterey Formation here. So this part of the Monterey Formation I would certainly classify as deeper oceanic waters. Up north around Monterey Bay, where the Monterey Formation was named, a lot of neat pecten fossils in there, and that part of the formation occurred in more shallower marine waters on a very shallow continental shelf, you know, maybe a meter deep at most. I would have placed this water pretty deep, probably 10 meters at least, considering the concentrations of the chert nodules. And so this ends our virtual video field trip of Crystal Cove. And I hope you take the time to come here after the coronavirus clears up. This is really a beautiful place. We were limited to access, so I kind of snuck in a lot of places. Did the best we could here. If we had been here on a field trip, we would have actually seen a lot more. So we're just making do with what we have. And everybody stay safe. And we'll get through this semester. And have a good day.